Okay, welcome back. Today we're going to do part two of learning some new factoring techniques for higher degree polynomials. Today we're specifically going to stay focused on binomials. So our objective still is students will solve higher degree binomials using factoring techniques. Our action verb is solve. What are we solving? Higher degree binomials. How are we going to do it? Using factoring techniques. And again, it's important to understand what the degree of a polynomial is. And remember, that's the exponent on the variable of the leading term, only when the polynomial is written in descending order. So that's key. And the previous, I'm sorry, this is found in 5.4 in your book. So if you need some extra help, you can go ahead and take a look inside that chapter. In the previous example, we learned factoring completely before we solved, which meant we had to factor twice. Today, we're going to look at some new special patterns. So I'd like you to pause the video and write the sum of two cubes, write the special pattern down, and the difference of two cubes. Go ahead and do that now. Okay, taking a look at these two patterns, I see a lot of similarities and some differences. First of all, I notice between the two patterns that the sum of two cubes obviously has a plus sign, hence the name sum. The difference has a minus sign, hence the name difference. As we look at the special patterns themselves, I notice they're similar in that the first set of parentheses, the first term is A, the second term is B. In the second set of parentheses, our first term is A squared, our middle term is AB, or A times B, and our last term is B squared. Okay, if we look at some differences, I notice the first term signs are different. This is a plus, this is a minus, hence the name sum. Notice that these two signs match in both examples, or both patterns. Okay, in the second set of parentheses, I see this is a minus, this is a plus, and both seem to have pluses at the end. I also notice that this middle, or this sign, the first sign in the second parentheses, is opposite of what's in the first. It's opposite. And we're going to use those characteristics to help us do this. To understand when I say AB, or A squared, or A times B, or B squared, that these are numbers that we get from our original problem that we're trying to factor. A is the number being cubed, and B is the other number being cubed. And hence the term is the number being cubed. Not the number itself, but the number being cubed. And we're going to take a look at that right now to see what I mean. Okay, let's start. I have two examples here. Let's bring up the first one. Let's work with this one. I think for this video, I think we're simply going to just factor and not worry about the solving aspect quite yet. Some of it may be beyond the scope of what we're doing, but our key skill today is being able to factor. So let's work with that. Okay, so given this equation, this is a cubic equation, meaning it has a degree of 3. There we go. Third degree. I will write better. Okay, so this is a third degree equation. So here's our steps in learning how to factor this guy. So the first step is to say how many terms. I notice I have two terms. This is a binomial. So in my brain, I'm going to the file in factoring that says two terms. And in two terms, I have difference of squares. I now have sum of cubes and difference of cubes. So I have three things in there, three ways to factor. Since this is a sum, I'm thinking sum of cubes. So the first thing I want to look at is, can I cube these numbers? Well, x is already cubed, so I know that's a perfect cube. What about 64? Can I cube root it? So with a quick factor tree, I can see if this is a perfect cube. So let's see, this is going to be, let's see, 4, yeah, it's not so quick, 4 times 16, and 4 times 4. I can see that 64 is a perfect cube. So I can rewrite actually I'm not going to rewrite it. I'm going to go over here and say this is a sum of two cubes. So I'm going to set up my special pattern. So I have one set of parentheses and another set that's kind of larger. One will be a binomial, one will be a trinomial. And I'm simply going to take the cube root of the first term and the cube root of the second term. The cube root of the first term is x. Cube root of the second term is 4. Now what we've created is what we call our A and our B, the number being cubed. From there, my special pattern says that my second parenthesis should be A squared, followed by A times B, followed by B squared. So I'm simply going to take this number, or letter X, I'm going to square it. There's your X squared. Then for the middle term, I'm going to multiply A times B, so this is X times 4, or 4X. And the last term is B squared, which is 16. So A squared, AB, B squared. Okay, now to get to the signs, I've got a trick to remember. It's a mnemonic device. We simply know the word SOAP. Okay, the word SOAP is an acronym that tells us the sign. So SOAP is S-O-A-P. We'll even call these dirty problems. You need to soap them up, because SOAP means, the first S means same, as in same sign. The O means opposite sign. And the A means always positive. We can remember SOAP, we've got our signs. Okay, so the first set of parentheses has the same sign. It's plus, so we're plus. The second set of parentheses, its first sign, the next sign will be the opposite sign. Since he's positive, we go negative. And the last term, or last sign, is always positive. From here, we are factored. Now our next step would be to look in to see if we could factor this trinomial using another technique. With a quick look, I don't see factors of 16 that add up to -4, so I think this guy's pretty much well factored, ready to solve. Okay, let's move down to the second example. Okay, it's the same technique. Let's go ahead and move him up. Go ahead and write him down. 16z to the 5th minus 250z squared is equal to 0. And again, we're not going to solve. We're simply going to just factor today. So when I look at this, I see numbers that just stand out to me as being kind of ugly. But remember, no matter how ugly it is, we know how to do it. We have our same set of steps. And our first step in all of factoring is greatest common factor. Now I know 16 and 250 are both even, so I know at least 2 goes into. If I do some mental calculations, I can try 4 or I can try 8, but I notice they don't go in there. So I'm simply going to do a GCF of 2, and I can pull out a couple z's, z squared, and that leaves me with 8z cubed minus half of 250 is 125, and the z's are gone. So we did greatest common factor. Now we're going to factor what's left. Now inside, I see a minus sign. I see 2 terms. So again, I'm in that file in my head, and factoring. It says binomials. How do I do it? Difference of cubes, difference of squares, sum of cubes. Because it's a difference, and this guy is cubed, degree 3, then I'm thinking difference of cubes. So I'm going to bring him down. If he can be factored, I'll have one small set of parentheses and one larger set. So in my mind, I'm going, can I cube root 8z cubed? Can I cube root 125? Well, the cube root of 8 is 2. The cube root of z cubed is z. And there is our a term again. Our b term would be the cube root of 125, which I know is 5. And notice I'm not putting the sign in yet. I'm going to hold off and do that last, because I don't want the sign to dork me up when I figured out my other numbers. So our next set of numbers will be our a squared, our a times b, and our b squared. So simply that means our first number squared, which would be 4z squared, not 2z squared, remember to square both of them. So our first number squared followed by, multiply the two numbers together, 2z and 5 is 10z, followed by our last number squared, which is 25. A squared, AB, B squared. And lastly, we're going to go back to the SOAP. Okay, so this sign is always the same. This one's always the opposite, and this one's always positive. So same sign, bring them straight down. Opposite, plus, always positive, plus. Okay, looking back in to see if I can factor. So quick mental factor, 4 times 25. This is a trinomial that's squared, so 4 times 25 is 100. Factors of 100 that add up to 10, 250, 425. Okay, I'm not seeing any, so I think we're pretty good to be factored. So at this point, we'd be ready to be solved. This guy would be quick and easy, set it equal to 0 and solve. This guy, however, would probably require the quadratic formula at this point. But we're not going to go there today. Our goal is to learn the sum and different cubes factoring techniques. So again, it's all about the a and the b, the a squared, ab, b squared, and SOAP. All right, so if you have any questions, you can re-listen to the video. If you still don't get it, jot it down to the side and we'll pick these up in class. Okay, thank you.